All right, let's get you prepped for your GCSE computer science exam. We're diving into a topic that honestly runs your entire digital life. Yep, we're talking about compression. This is everything you need from section 1.2.5 of the spec, so let's get you ready to ace this. I mean, we've all been there, right? You go to take a photo and bam, storage full. Or you try to email that big project file and nope, file too large. It's just one of the most annoying things in our digital lives. And this is what we call the storage space squeeze. We've got these amazing high-res photos and 4K videos, but our poor devices are just struggling to keep up. But thankfully, computer science has a really clever solution. Okay, let's get into it. The solution is called compression. At its heart, it's a super smart process for taking a file and figuring out how to represent the same information or pretty close to the same information using way fewer bits. Fewer bits means less data, which means a smaller file. Simple as that, really. So you can really think of compression as the hero of our modern digital world. I mean, without it, trying to stream Netflix would be a total buffering nightmare, and your phone would be full after about 10 photos. It literally makes everything we do online possible. Now, for your exam, this is a big one. You absolutely have to know why we use compression. And the reasons are all around us. It makes sending emails and downloading stuff way faster. It saves that precious storage space on our phones and laptops. It helps websites load in a flash. And of course, it's what makes streaming music and videos so smooth. These are your go-to answers. So how does this all actually work? Well, it turns out there are two main strategies for shrinking a file. And listen, the exam spec is super clear on this. You need to know both of them, what they're good at, what they're bad at, and what they actually do to the file. This is the real core of the topic. So the two methods are called lossless and lossy. Here's a great way to think about them. Imagine lossless is a total perfectionist. It needs every single piece of the original to be put back perfectly. Lossy, on the other hand, is more of a pragmatist. It's willing to get rid of some less important stuff to get a much, much smaller result. So let's start with the perfectionist, lossless compression. Just like the name says, its whole goal is to make a file smaller without losing a single bit of information. Zero loss. The big advantage here is obvious, right? No data is ever lost. You can compress a file and then decompress it, and you'll have a perfect, bit-for-bit identical copy of what you started with. The downside, though, the trade-off, is that the file size doesn't get that much smaller. You save some space, for sure, but it's not a massive reduction. And this is the key takeaway for lossless. The effect it has on the file is that it's completely reversible. Think of it like packing a suitcase really, really neatly. Everything you put in, you can take back out in exactly the same condition. Nothing gets left behind. And now for the other one, lossy compression, the smart shortcut. Now this approach is really clever. It basically makes a bet that it can throw away some data that our human eyes and ears probably won't even miss, like tiny color differences or sounds that are too high for us to hear, all in the name of making the file way, way smaller. The advantage is huge. I mean, you get these dramatically smaller file sizes, which is a total game changer for things like streaming or putting images on a website. But the disadvantage is a big one. That data it throws away, it's gone. For good. You can never, ever get it back. So the bottom line, the effect on the file is that the quality is reduced. You might not always notice it, but it's a fact. And unlike that neatly packed suitcase, this is a one-way trip. The process is totally irreversible. You can't uncompress it and get the perfect original back. So this brings us to what's probably the most common kind of exam question you'll get on this. It's all about application. Knowing the definitions is great, but showing you know when to use which type of compression, that's how you really prove you get it.
Okay, this table right here is your secret weapon. Let's walk through the logic. If you've got a text document or some computer code, could you afford to lose a single letter or a semicolon? Of course not. The whole thing would break. So it has to be lossless. What about streaming a movie? Well, a tiny drop in visual detail that your eyes probably won't even catch is a fantastic trade-off for a movie that plays smoothly. That is a perfect job for lossy. Now, something really important, like a medical x-ray. You cannot risk losing a single pixel of diagnostic information. It's got to be lossless, no question. But a profile picture for your social media? A smaller file that loads super fast is way more important than having a perfect uncompressed image. So lossy is the obvious choice there.
Right, we've gone through all the main ideas. Let's just lock it all in with a final quick-fire summary. This is the stuff that absolutely has to be in your head when you walk into that exam hall. Okay, let's burn this into our brains. Ready? Lossless. It's reversible. You lose zero data, but the file is bigger. Lossy, it's irreversible. You lose data forever, but the file is way smaller. You use lossless for anything that must be perfect: text, code, critical data. You use lossy for media, images, video, audio, where that huge file size saving is worth a tiny dip in quality. Got it? Perfect. And to finish up, here's a little thought experiment for you. Just pick up your phone. Think about your photo gallery, your music app, the videos you've saved. Which of these two compression methods we just talked about is the real MVP, the unsung hero that's doing most of the work to stop that dreaded storage full message from popping up? The answer is literally in the palm of your hand.